Okay, ladies and gentlemen, we're going to wrap up section 5.3 by looking at scientific notation and operations with those types of numbers. To start, let's review quickly the strict format for scientific notation form. Of course, scientific notation format is this right here, where this number A has to be either a 1, a 2, 3, 4, 5, 6, 7, 8, or 9. Cannot be any other digit or digits. Okay. All right. So before we're able to multiply and divide scientific notation form numbers, we're going to have to learn how to adjust numbers that look like they're almost in scientific notation form but are not. For instance, suppose I have the number here 21.3 times 10 to the fourth power. This looks like it's in scientific notation form, but it is not according to the format above. To get this into scientific notation format, we would have to move the decimal point one place to the left and force it between the 2 and the 1. Because to the left of the decimal point has to be a digit that's either, one of these digits in this list above. Now, this is something that you want to try to remember. I came up with a little saying to help out with this. My little saying it's a little rhyming saying. It says this: to the left, we heft. Okay? If we move the decimal to the left in a number, we have to heft up the exponent. So I'm going to have to shift my decimal point one place to the left, but if I do that, I'm going to have to add 1 to my exponent. I have to heft it up by 1. And so therefore, to put this in scientific notation form, this would really be 2.13 times 10 to the 5th power. Now this is strictly in scientific notation form, but notice this number is still equivalent to our original number we started with. Okay. Let's try another one. If I have the number 0.246 times 10 to the 5th power, notice this number is not in scientific notation format, because to the left of the decimal point is 0, and 0 is not one of these digits in this list above here. To put this into scientific notation form, we're going to have to shift our decimal point, in this case, one place to the right, and put it between the 2 and the 4. So that to the left of the decimal point will be 2, which is one of the digits in this list above here. Now, my sayings to remember this says this: when you shift the decimal point to the right, we slight. In other words, when I shift my decimal point one place to the right to put it between the 2 and the 4, we're going to have 2.46 times 10. Now, since I shifted my decimal point one place to the right, we're going to have to slight the exponent by 1. In other words, we decrease the exponent by 1, so it'll now be times 10 to the 4th power. Now this number is in strict scientific notation form. But notice it's still equal to the original number we started with. All right, let's try maybe a couple more here. Suppose I originally have the number 213.2 times 10 to the negative 4th power. This number is not in scientific notation form because to the left of the decimal point is the number 213, and 213 is not one of these digits in this list above here. So to put this number in the scientific notation form, we would have to shift the decimal point 2 places to the left to place it between the 2 and the 1. So therefore, to write this in scientific notation form, we would have 2.132 times 10 to the, now, I went to the left with my decimal point 2 places, so I have to heft. To the left, we heft. So we're going to have to heft up our exponent by 2. So negative 4 plus 2 is negative 2. So this will be times 10 to the negative 2 power. This number now is in scientific notation form, and it's still equivalent to our original number back over here. All right, one more. Suppose we have 0.0329 times 10 to the 4th power, let's say. This number is not in scientific notation form because to the left of the decimal point is 0, and 0 is not one of our digits on this list above here. To put this into scientific notation form, we would have to shift the decimal point 2 places to the right to place it between the 3 and the 2. But to the right, we slight. So therefore, we would write this as 3.29 times 10 to the, now I move my decimal point 2 places to the right, so we slight the exponent by 2. In other words, decrease it by 2. So 4 minus 2 is 2. So this will be times 10 to the second. This number now is in scientific notation form. So that's how you adjust a number that looks like it's in scientific notation form, but not exactly. Now we can begin, armed with that knowledge, we can begin to actually multiply and divide numbers that are in scientific notation form. Okay. So let's try to simplify the product of these two numbers that are in scientific notation form. 3 times 10 to the third power multiplied by 2 times 10 to the fifth power. To multiply numbers that are in scientific notation form, we have to basically multiply like bases together. So the 3 will have to get multiplied by the 2 times, and then the like bases of 10 have to get multiplied together. So 10 to the third power has to get multiplied by 10 to the fifth power. Now 3 times 2 is 6, so we have 6 times, and 10 to the third times 10 to the fifth. When you multiply like bases, you keep the base the same and you add exponents. 3 plus 5 is 8. And ladies and gentlemen, that would be the product of these two numbers that are in scientific notation form. 6 times 10 to the 8th power, which is a pretty big number. Okay. All right, let's try another one. How about 7.1 times 10 to the 5th power? And we're going to take that number in scientific notation form and multiply it by 2 times 10 to the negative 8th power. Now, to multiply these numbers together, we're going to multiply it like bases together. So we're going to multiply the 7.1 by the 2 times, and then we're going to multiply like bases of 10 together. So 10 to the 5th power will get multiplied by 10 to the negative 8th power. Two times 7.1, you can work that off to the side here. 7.1 times 2 is going to be 214. So one place to the right, one place to the left, 14.2. So it's 14.2. And then 10 to the 5th multiplied by 10 to the negative 8th, when you multiply like bases together to keep the base the same, and you add the exponents. 5 plus a negative 8 is negative 3. But ladies and gentlemen, this number is not in scientific notation form, because to the left of the decimal point is 14, which is not 1, 2, 3, 4, 5, 6, 7, 8, or 9. So therefore, we're going to have to shift the decimal point one place to the left, and since we went to the left, we're going to have to heft our exponent by 1. So this will therefore be 1.42 times 10 to the, now negative 3 plus 1, as we heft up our exponent by 1, would be negative 2. And that is the number in scientific notation form as being the product of these two numbers back over here. Okay. 3.4 times 10 to the negative 2. We're going to take this number, which is in scientific notation form, and multiply it by 4.5 times 10 to the negative 6 power. Now 3.4 times 4.5, you can do this off to the side of your paper. 5 times 4 is 20, carry the 2. 5 times 3 is 15, plus 2 is 17. Put a 0. 4 times 4 is 16, carry the 1. 4 times 3 is 12, plus 1 is 13. Now it's 1, 2 total places to the right with the decimal point, so it's 2 to the left in the answer. 1, 2, so 15.3 or 15.30. I'm just going to say 15.3. Okay, so that's the product of 3.4 and 4.5. Times, now we have 10 to the negative 2 power multiplied by 10 to the negative 6 power, and when you multiply like bases together, you keep the base the same and you add the exponents. Negative 2 added to a negative 6 would be negative 8. Well, ladies and gentlemen, again, this is not in scientific notation form, because to the left of the decimal point is 15, which is not 1, 2, 3, 4, 5, 6, 7, 8, or 9. So we're going to have to shift our decimal point one place to the left to put it between the 1 and the 5. Now to the left, we heft. So 1.53 And then we're going to have to heft our exponent up by 1 because we moved our decimal point 1 place to the left. So negative 8 plus 1 is negative 7. And that's your final answer for that problem there. So here are some examples as to how to multiply scientific notation numbers together, and then how to make a subtle adjustment in the end if need be necessary to make sure the answer is in scientific notation form. Okay, how to divide numbers that are in scientific notation form. Let's take 8.4 times 10 to the 5th, and let's divide it by 2 times 10 to the 2nd power. So to divide these two numbers that are in scientific notation form, we basically split up like bases. So we put the 8.4 over the 2 times 10 to the 5th divided by 10 to the 2nd. Now 2 divides into 8.4. 4.2 times. And then 10 to the 5th power divided by 10 to the 2nd power, when you divide like bases, you keep the base the same and you subtract the exponents. 5 subtract 2 is 3. And we're lucky here because this number, as it turns out, is in scientific notation form. So that would be the proper quotient for this answer, for this problem back over here. All right, let's try another one. How about 2.5 times 10 to the negative 6th power? And we're going to divide this by 5 times 10 to the negative 4th power. Again, we will split this up here, put 2.5 over 5 times 10 to the negative 6 divided by 10 to the negative 4th power. Now 5 divides into 2.5 how many times? Well, we'll do this off to the side of our paper here. 5 divides into 2 0 times. 5 divides into 25 5 times. And so therefore 2.5 divided by 5 is 0.5. And when we divide like bases of 10, we keep the base the same and we subtract the exponent. So this would be 10 to the negative 6 subtract negative 4 power. Numerator minus denominator power. Hence, this is 0.5 times 10 to the negative 6. Subtracting a negative 4 is adding 4. Hence, we have 0.5 times 10 to the negative 6 plus 4 is negative 2 power. Now, ladies and gentlemen, this number, however, is not in scientific notation form. We're going to have to shift the decimal point 1 place to the right to ensure that the digit to the left of the decimal point is a number of 1, 2, 3, 4, 5, 6, 7, 8, or 9. So we must shift the decimal point 1 place to the right, in which case we'll have 5 point. But since I shifted my decimal point 1 place to the right, we slight the exponent. To the right, we slight. So 1 place to the right, we slight the exponent by 1, meaning we decrease the exponent by 1. We decrease it by 1. So this would be times 10 to the negative 3 power. And that would be your final answer for that problem there. All right, one last problem. This will be kind of the grand finale. Suppose I want to take a scientific notation number 8 times 10 to the 4th. And I want to multiply that by 5 times 10 to the 10th power. Then I want to divide this whole thing by 2 times 10 to the 7th power. Now, to do this problem, we're going to have to break it up into steps. First of all, I'm going to have to multiply the 8 by the 5. 8 times 5 is 40 times, and then I'm going to multiply my like bases of 10 together. So I'm going to take 10 to the 4th power and multiply by 10 to the 10th power. And of course, when you multiply like bases together, you keep the base the same and you add the exponents. So 4 plus 10 is 14. And that's going to be divided by 2 times 10 to the 7th power. Now to do the division of these numbers, we're going to split this up, putting 40 over 2 times, and then we'll divide 10 to the 14th power by 10 to the 7th power. Finally, 40 divided by 2 is 20. Times 10 to the 14th divided by 10 to the 7th, we subtract the exponents when we divide like bases. 14 minus 7 is 7. But unfortunately, this number is not in scientific notation form because to the left of the decimal point is 20. To put it in a scientific notation form, we have to shift the decimal point one place to the left and place it between the 2 and the 0. Now, to the left, we heft. So this will be 2.0, or just 2, times 10 to the, we heft this exponent up by 1 since we shifted the decimal point to the left by 1. So 10 to the 8th power. I would just say 2 times 10 to the 8th, and there's your final answer. Okay, ladies and gentlemen, that wraps up section 5.3. I wish you the best, and the key is try to stay up with this work and not get behind. When you get behind, it's going to become miserable and very difficult to catch up. Times are bad, but they could be a lot worse. Let's at least try to give ourselves the best opportunity to succeed in this course. I wish you all the best. Take care.